Okay, so I guess we're live now. Hopefully the stream won't freeze because it did during testing, and I'm not sure yet if it was OBS or my internet, so yeah. Let's see how many people we have at the moment. Okay, it's 1 on both platforms. That's nice. Anything better than 0, I guess. Yeah, I think we can wait 2, 3 more minutes before starting. So for today, we have quite an interesting topic. It's operational transform algorithm. And yeah, I'm pretty excited about it. I was looking at all the articles about it. Yeah, hope you don't mind parrots. They could be quite loud, so I hopefully they won't interrupt me a lot. Anyway, yeah, I was researching the OT for like a week now, and it's a fascinating concept, you know? So, okay, so somebody left from YouTube, so we have 1. Anyway, I guess for now we're good, so let's start. Let me switch to my slides here. Okay, so we are doing operational transform. And what is operational transform? It's an algorithm for collaborative work, basically. By that, I mean when multiple people work on the same document, object, whatever, and it's a pretty big concept. There are multiple algorithms to do that, but we'll be talking about specifically operational transform. So who uses operational transform in the first place? Oh, I guess my slides are slightly broken. Anyway, so yeah, so what's OT? As I said, it's an algorithm to work on the same document at the same time for multiple people. And it's not only applicable for text, but it's also basically for any data type. And the main difference from other algorithms is that OT requires like a third-party client that will be an authority that will be ensuring that data is consistent and stuff like that. So who uses? Oh, yeah. That's wrong. Yeah. So who uses it? And you really know many of the companies that utilize operational transform, for example, Figma, Google Drive, and specifically Google Docs, Office 365, and Miro. And many more. Not any, but most of collaborative tools have some sort of OT implementation or other algorithms like that. For example, CRDT, it's a conflict-free replicated data types. It's an alternative for OT, and the key difference here is because how it operates, it can be used without a third client, an authority, so clients can, users can communicate with each other directly without third party. I mean, third party is required in cases where you want to synchronize your data, for example, on a server, but it's not required, and you can do that like peer-to-peer. So, how does it work? as the name suggests, operational based, meaning that every action in this algorithm is an operation. And for example, it can be, in case of text, for example, it can be insert, delete, or even update parts of the text. And all the operations are executed in a sequence. So the order of operations is required. And as I already mentioned, OT requires an authority. So yeah, let's see how it works in a nutshell. So let's imagine we have 2 clients and a server, and all of them has a text XYZ. So when they want to make a change, for example, client 1 adds character B to the string, and client 2 removes X from their text. So these 2 operations, no matter which one was first, will be sent to the server in exact order that these operations were performed. And this means that on the server, we will have a string XYZB. Then the server will resolve the operation. So it will receive 2 operations, one for removal, one for addition. And it will resolve the conflict, or in this case, it's not a conflict, but like 2 changes to the text. It will resolve the order of operations. Basically, for the server, it's just whose event came first, whose operation came first. And then, after resolution, we will see that both clients now have YZB, and the server also has YZB, so data is synchronized again. And that's pretty much everything that OT does. So to recap, it accepts operations. No matter what it is, you can define any types of operations. Depending on your data type, it can be, for text, it could be insert, delete, update. For any other type, whatever is suitable for the specific data type. Okay, so that's like a brief introduction to OT. And now we want to plan a little bit for what we're going to do. So we're doing a collaborative text editor. It will be a pretty simple one. We don't want to go all the way into implementing the algorithm, at least today. Maybe in like next streams, I will be improving and scaling the algorithm to something better, something more capable, I guess. But for today, we're implementing basic version of it. So on the front end, we will have just 2 text areas, and we will implement the algorithm itself, and the final goal will be to have 2 browser windows not connected to each other anyhow, that can communicate with each other using the backend WebSocket server, and 2 clients working on different browser windows will be able to synchronize their text and work basically on the same text at the same time. Yeah, so that's for the plan. Now I guess we can switch back to code and start doing that. Let me go over to my terminal. I'm already in my streams folder. It's empty right now just because it's my first stream. Hopefully there will be more, but anyway, so let's create a folder for us. I guess it will be, I don't know, basic OT. And I will be using Svelte as a framework to just make things easier a little bit. So for Svelte to start, we will be doing bun x sv create. I can't type today. Create. Okay. So yeah, we're using current directory. We will be using minimal SvelteKit app. We will be using TypeScript, and we will need vtest. We don't care about styles and stuff. It will be basic text areas. We're using bun as a runtime. So let's see. Now we have a bunch of files here. Let's see. So yeah, I'm using tmux here, so I will create a new window. Why it's not working? Why it is not working? We'll do the old-fashioned way. Okay. Yeah. So this window will be specifically for running running web server. So bun dev open. And now we should see the basic SvelteKit app. Okay, let's switch back, and I'll open my editor here just to check that everything works. Let's go to the main page. You can see that's the same welcome page. And let's see. Yeah, works just fine. Okay, so for now, let's just add a text area here. That will be our main entry point. I promise that's all the front end will kind of do. I mean, all the styling. I want to make it a little bit bigger. So not that big. I really can't type. And font size will be, I don't know, 21. Okay. Yeah, that's it. Okay, so that's all about the front end for now. We will be setting up a WebSocket server. We will be, by the way, I'm talking here and I didn't ask if you can hear me. Can you hear me? Drop a message in the chat if you can. If you can't, I guess you won't hear what I'm saying. Okay, yeah, I will assume that you can hear me because nobody writes anything. Okay. Oh, that's interesting. Okay. Yeah, so let's get back to the editor. Okay, so we will be, for now, working on the algorithm kind of blindly because to make it work in the browser and on the server, we will need some to make some preparation. But I want to make sure that the algorithm itself works. For that, we will be using vtest as a testing framework, and we will be writing code and testing until we have some sort of working solution, okay? So let's go to, I guess I will create a library, yeah. So we have a lib folder here, And I think we're good with just OT directory here, index.ts. Now, so it will be a single class, OT, like that. And there are a few requirements that OT, in our case, will have. First of all, we want a constructor that will be accepting a document. Document in our case will be just a string. Basically, it's a text that we're working on. And I will create a couple of properties here. Not sure yet if we will need them. But it's something. And now we need a way to create operations. First of all, I want to define an operation. So let's create a types file where we will be creating all the types. And first type we will have is can you just stop? Let me know if they're too loud. I will move them somewhere else because they can be too loud. Interesting. Okay, so yeah, so types for the operation. We will have a basic type, and this operation type will be just a container that holds information about what we're doing. Basically, it will have, for now, it will have index, which is number, and string, which is string. So what is operation? Operation defines what changes were made to a specific object. In our case, it's text. So we will be, oh, and also we need type. And type will be export enum operation type. So what I'm thinking that we for now will have insert, which is insert, and delete, which is delete. Yeah. Okay. And here in type, we will have operation type, like that. So, yeah. Operation defines a change to the text we want to perform. For now, we have insert and delete. Index defines where the change was made in the text. So, for example, we have a string hello. Let's just do it here. We have a string hello, and we want to make a change. For example, we want to delete a word, not a word, but letter E. So in this case, the operation will be something like this: type operation type delete. Index will be 1 because we start counting from 0. So this is 0. You can imagine like a cursor that goes behind the character that you're selecting. So in this case, 0 will be here, 1 will be here. So we're deleting 1, and we set string to be B. That will be operation. Same for insertion, we just define a different type and where we want to place an inserted character. What's cool about this algorithm is that you can also insert multiple characters. For example, we can insert a whole text, and that's basically what we're going to do in the first in the initializer here in the constructor. So there are a couple more things that we need. We need a history that will hold a list of operations. So it will be operation array of it, and I guess we can initialize it with empty array here. Yeah, one more reason that I can type today is because I'm still getting used to a new layout here. Yeah, and some characters here are kind of crumbled together. Okay, so we have a history. Now we can also, I'm not sure, but let's try, let's just for like a future proof, let's create an operation. TS, like that, and we will export class. And if we do that, we don't need a separate type. So we will have constructor that accepts type equals operation type, index, which is a number, and string, which is string. Now we want to define those parameters here. Type will be operation type. That's embarrassing. Index will be number, and string will be string. There was some sort of a shorthand to not assign those parameters in the constructor function, something like this, or maybe this, I don't remember. So we will do the old-fashioned way. This dot type equals type. This dot index equals index, and this dot string equals string. Okay, yeah, so this is our operation. Maybe, yeah, we will be doing like all the merge and collapse things inside inside here. Maybe not all the operations, but some of them, like conflict resolution. We can merge two operations together through this class. Okay, so now let's go back to our index here, and I will define a new method, create operation. And it will have the same signature. Type will be operation type. Index will be number, and string will be string. And we will do history.push, push new operation, type index string. Okay, cool. Now let's clean it up a little. First of all, we don't need this type here. Also, I guess we can get rid of this. Let's go back, and we don't need this as well. Okay. Yeah, so that's the first thing we do. Now, how do we initialize this all? Basically, the first, the moment we want to load a new document is just the first operation in the list, and it's as simple as just getting a document string here, and using it as a string for the operation. So we just do this create operation, create operation. We will be doing insert, so it will be operation type insert. At index 0, we will just be inserting document. And there are two approaches to do this all. First one is to directly communicate with the document and adjust it in the OT itself on the server, for example, and sending back just ready to use text. The second one is operating only on operations, no pun intended. This approach might be more performant, not necessarily, but can be. So yeah, that's basically what we do for now. Let's create a test. No, I want it to be here. Okay, and we will create a folder tests, and it will be ot.test.ts. Let's write it down, open, and yeah, as we already have vtest initialized, we will be just doing describe interesting. That's curious. For some reason, it doesn't seem to recognize that we have vtest installed. Cannot find name describe. Okay, let's try catting into package.json to see if we have vtest. No, we don't. Interesting. So let's just add vtest to the stack. Vtest. Oh, like that. And now we can go back. Apparently, I need to restart my LSP. Okay, yeah. Now. from retest. Yeah, now we have it. Now, first test will be can initialize with document. And this one will be a pretty simple test here. Probably the simplest we will have. So we're just initializing our algorithm, our let's call it somehow collaborator. No, that's bad name. Let's call it library. Our library. Okay. So we're just validating that our library can be initialized with text, and it's actually held inside the instance. Okay, so expect OT document initial document to equal hello world. Okay. We also need to, we don't have a command to actually run tests, so let's go back down here, and I will add a command test. That will be just doing on read. Okay. Yep, and we can see that our test successfully passes. So what's next? Oh, by the way, interesting, is my... Oh, cool. We can run tests right from here. So, let me close this. Now, one more thing we want to check is that we have an operation stored inside the history. Expect OT history at 0 to strict equal to do we have dip equal? No. To equal type insert. No. Operation type insert index 0 string hello world. Let's rerun the test, and it passes. Okay, cool. So now we have now have our initial things tested and working. That's cool. That is cool. So what we do next is we actually need to start merging, like accepting operations and merging them. Sorry, just a second. I'm not sure in which. Yeah. Okay. Okay. So yeah, so the next step would be to process incoming operations. For that, we need a method. Let's call it process operation. It will accept you know what? Considering that we will be, oh no, that's not a problem. We can, yeah. So what I'm thinking is that as we will be communicating over WebSocket, there's no way we can transfer actual classes between client and server. So we need some sort of a layer where we will be creating operations from JSON. For that, I guess we can go to, whoops. Yeah, for that we will be doing, let me expand this a little. First of all, let's go to operation.ts, and I want to define a static method here. From JSON. And what it will be doing is it will be taking operation in its raw format. So we shouldn't be deleting the operation here in types. Type. So this will represent a JSON type. I forgot about equals here. Okay, yeah. So this operation raw will represent a raw JSON that we can transfer over the network. Again, because we can't pass classes, unfortunately. So here, operation will be operation raw. This guy here. And everything we're doing here is just returning an operation where we will be doing operation type. No. Type. Operation dot index and operation dot string. Okay. Actually, we can add something like Zod to validate the structure, but for now we don't care about it. Yeah. So the next step would be to add a test. Should accept raw JSON. And everything we're doing here is we're just creating operation equals operation from JSON. And we're assuming that JSON already have been parsed. Excuse me. And it's not just a basic string. Okay, so we will define type as operation type insert. Index, it can be arbitrary number. Let's say 5 to 56. And string will be something like that. And what do? We need to confirm that operation is what's wrong with me? I can't type today. Sorry about that. Instance of okay. And we also want to check every field inside operation. Type to equal operation type insert and string of index to be 256 and string to equal hello operational transform. Okay, let's run it, and it failed. That's interesting. Nope. Let's see what it does. The instance of assertion needs a constructor, but oh, okay, yeah. My bad. Oh my god. Let's rerun the test, and now it passes. Okay, cool. So we now can parse JSON. We can create operations. Let's start the fun part. Now we need to process our operations. So processing operation means that we want to add a new operation and we want to transform new operation. So transforming operations mean that we take the last operation in our history, we take the new one, and we compare them. And this is used for conflict resolution. For example, if we have an operation on the same index. So for example, let me just show it. So we have, for example, hello again. We have client 1 deleting and client 2 adding I don't know, B. Add index 0, 1, 2, 3. 0, 1, 2, 3, 4. Add index 4. Okay, and they both do that at index 4. So in this case, we don't know what to do. And that's where different approaches to conflict resolution come in. For our case, we will be doing a merge resolution approach, where we basically take, so one, probably the most popular, is to just whoever got last wins. So for example, in this case, depending on in which order the operations was, we either accept this one if it was last, or this one if it was last. We can also prioritize like whoever first wins, So if this operation was first, we just accepting addition of b. If this one was first, we just accepting that there's no character O anymore. And there's merge. Merge basically means that we need to compare two operations and identify the sequence of additional operations that needed to resolve a conflict. For example, in this case, if we have if we have this hello, we can clearly say that after so let's imagine that deleting was first. Okay, so there will be two operations, and considering that there's index 4 here and it was first, after this operation we will have hell. But this change was also on index 4, and we need to shift this index before we can continue. So how do we do that? Basically, we compare two operations, and if first one was deleting, then the next one will be will change its index. Same goes for addition. So for example, in this case, we will have operation looking like that. We have delete at index 4, letter O, and we will have length of 1. That means 1 character removed. And we have second operation, insert at index 4, letter B, length of 1. Okay, so when we merge these two operations, we will end up with a new operation that will say insert B at index 3, because we are considering that we will have two identical indexes. We need to subtract the length of delete operation from this index, in this case 1, and that's why we get 3, and length will be 1 again. So there will be two operations, one delete and the second one is insert. So after the transformation, we will have two operations: delete 4 at index delete in O at index 4. Let's add some unification here. At index 4 with length of 1, and then we insert B at index 3, because it will be the last index after deletion. So at this point we'll have hell 0, 1, 0, 1, 2, 3. So at index 3 we insert B, and that's how resolution works here. So now we want, let's go back to code. Okay, we want operation, process operation. What is going on? What process operation will do? Let me check the chat real quick, if we have anything in the chat. Yeah, and beam, by the way. Love it so much. Okay, so process operation will be doing two things. It will be taking operation, comparing it with all the past operations in the list. So it will be something like for let operation of this stat history, because that's where we, oh, wrong file, go back here. Yeah, so this history, and here we will be transforming our new operation, incoming operation, into a new operation. So basically we're comparing all previous operations with the new one. And we will have let new. This will be the last operation that we will be adding after comparing it, this incoming operation with all the operations we have right now. So we will assign operation here, and after that we will have this transform operation, okay? Oh, and by the way, we'll be doing new operation here. I could have just mutate this variable to avoid this reassignment and stuff, but it's a bad practice to reassign arguments, so we will not be doing that. And now the only thing that's left is to push our operation to the history. History, push new operation, and we will return it like that. Now we need the transform method, and then we will write a little bit more tests. Okay, so this is where we start comparing operations with each other. So we need to compare our operations with so we're comparing OP2 with OP1. So OP2 will be always the new operation. OP1 will be the operation that precedes it. Ooh, I just forgot that I didn't turn on Do Not Disturb. Okay, yeah, because if any notification come, it will be annoying. Okay, so yeah, so we're doing transform, and let's create transformed operation. It will be OP2. So if OP2, so basically, depending on the transformation, we can just end up with just transformed operation being just OP2. Okay, so just for that, we will return transformed right away. And I will make it let. I have no words. Okay, so here I will just switch on OP1 type. So now we need to, depending on the type of operation, we will be comparing slightly differently. And why I'm taking OP1 here is because if you remember how we compared in the example, where it was in operation here, before we do anything, we need to compare these two. And basically, we need this length to be subtracted from this index here. So we will be going, depending on the type of operation A, operation 1, whatever, in our case, OP1, I guess. Yeah, OP1. Depending on the type of operation on OP1, there could be different outcomes for the final operation. So now let's try for operation type insert. We'll just break right away. And what we need to do is to compare how operation works here. So as I said, it doesn't really matter what operations go next. We always want to adjust to the index of previous operation. So basically, if OP2 is deletion and the index of it is larger than the OP1 index, basically if OP2 index is larger than yes, finally, thank you. OP1 index and yeah, larger than OP1 index. Everything we want to do is to just adjust the position of transformed operation we defined in line 5. So transformed index will be so we just adding, yeah, we're just adding to it information from operation 1. String length. And that's our operation insert. Let's write a test for it. So we want to ensure that we are correctly inserting the new operation. So I will just copy this here. And we already have one operation, right? And what we want to do is we want to delete the entire word here. So let's add OT process operation. Whoops. Okay. OT process operation. And we're just adding a new operation here that will do type operation type delete index. Let's see, 1, 2, 3, 4, 5, 6, 7. Okay, at index 7, and string world. Oh yeah, we don't need keys here. Okay, now we have our operation, and what we're checking is that the last operation here will be an operation that has. Okay, let's do a little bit more complex thing. So OT process operation, new operation. So I want to make it a little bit more complex here. So we will first do operation type insert. Add I don't know, let's just add a word in between, okay? So we want to add, let's find an index, 1, 2, 2, I'm sorry, 0, 1, 2, 3, 4, 5. Okay, yeah, it's index 5. Oh, by the way, it's index 4. Sorry, index 6. And this one will be index 5. And we insert a word, I don't know, banana. Okay, so in the end, we want, so this index will shift by 5. So we should end up in the situation where we, where the last operation will be delete operation at index 11. Okay, so we just confirm that. Expect OT history at -1. I love this add method. It allows finally to, for example, take a last element of the array. So we want it to be equal. Oh, that's interesting. So we don't have. Oh yeah, we can basically just confirm that. I think we need a to-JSON method on operation, because we will be converting operations to JSON anyway. So maybe let's add it just now. Let's go to operation here, and line 10 here we will do to JSON return I guess we can just do this. And yeah, so let's create let's grab our operation. Let's grab our operation here. We also want to be sure that this operation exists at all. Now we can get rid of this. No, we can't. Okay. And we want it to be equal to an object where type is operation type delete. Index will be 11, and string will be still hello. And let's try. No, it fails. Should correctly implement operation to JSON is not a function. Oh, that's interesting. That's interesting. Did we push the transformed operation? Oh no, that should be. Who's an idiot? Me or not me? Probably me. I'm writing the code. Insert. Oh yeah, right. We don't have. No, we're operating on the previous operation here. So transform should property to JSON is missing in type. What? Oh, yeah. We're operating on JSON here. So, from JSON transform. Okay. Index 23. That's interesting. That is interesting. Why it's 23? Let's debug it. Yeah, that's another cool thing about NeoVim that already mentioned in the comments. The cool thing is that, like in VS Code or any other IDE, I can debug code right in the editor. Let's see if there's any comments. No, there's not. Okay, cool. Yeah, so I can do, for example, leader db to add a breakpoint, and now run with debugger to see where we stop. Oh, no, okay. I'm still not getting it. So OP1, 0 index. Oh, wait a second. Right. Why not? OT process operation. That's interesting. So it feels like when we. Oh no. Okay. So we have operation 1 inserts hello world. Operation 2 also insert banana. Okay. So it will be index 5. Oh, okay. So no, it should be fine. Okay. Let's continue. operation. Oh, interesting. So there's still one operation. But how it ends up with index 25? 25. Let's see. 5, 6. There's no 2. Okay, so it's not strings or something. So what could it be? What could it be? Let's see. 3 times. Interesting. Okay, I guess we need to implement inserts first before we can test it. Because I'm not sure I understand correctly what's going on. Okay, so this is for our insert. Oh, I mean delete. Now, for delete, we will have something similar. So basically, what we're doing here. Okay, so basically, what we're doing here is we need to adjust the index again when pretty much the same thing applies. So we only care about these indexes when index operation 2 is greater than previous operation. Okay, so there will be the same expression. Will be the same expression here, and the only difference will be is that we are comparing not only indexes but also a difference between length of text. Okay. Oh yeah. So in a nutshell, it will be something like transform index equals not equals. Actually, it will be minus equals. So we're subtracting the new index from existing one, and we need like a minimum number, like a minimum index. So we will be doing math min to compare two numbers. Next, yeah, I guess we can do it in either order. So we're comparing string. And here we want a difference between two text, two positions. Okay, so we want a difference between position 2 minus OP1 index. So we're taking a minimum number of, so we're taking OP1, which is a preceding string state, string change, yeah. And we also subtracting index next minus index previous. And as it only happens if OP2 is farther than OP1, so we always should get a positive number here, which means that we always end up with a positive index. There's no way we can end up, for example, with negative index. Now we have this stuff implemented. Let's try again with our test. Still fails, but now we have index 23 at delete. Okay, so let's see. If I'm correct, there will be three operations now. First one is invisible because it's done by the constructor itself. We create new operation, insert add 0, and we insert hello world. Okay, so we insert hello world as a first operation. Then we insert banana at, let's actually do something slightly simpler. So we will test correctly transform insert operation. Yeah, so we just, we don't need delete here, okay? We just need to confirm that this thing will be the same. So if we go down here, we should see index 5, banana, and insert. And now, no, still not passing. 16. Interesting. Interesting. Really, really interesting. Why it's 16? It should be 16. How could it be 16? Let's check. Do we have this one passing? Yeah. By the way, we compare. I guess we can do that. So let's type insert. Okay. Index 16. That's kind of weird. It shouldn't be 16, it should be 5. It should be still 5. So let's see the logic. Insert. Insert, so we have our operation to be, so the first OP will be operation with insert at index 0. Will it? Let's confirm that. First of all, we don't need this check, so we can just, oops. Do this, and for this operation, we will take ot.history dot at 0, And what we need to confirm here is that it's insert operation at index 0, and it has text of hello world. Okay, so this is our initial operation. Okay, let's run it and see. Okay, so it kinda weird. Oh, okay, yeah. So okay. Okay. Assertion error. Insert index 0. Maybe I'm not getting something. Well, no, I should work just fine. Oh, I'm an idiot. Okay, so at least we're moving somewhere because this part passes. Let's see. Yeah, we still have weird index here. I'm not sure why, but the previous operation passes. So where does it get? Okay, I guess it does. So we insert banana, okay, and we have 5 here, and we are taking okay, let's see. So we have our 0, we have our 5, and if index of operation is more than index of previous operation, which is true, we fall into this if statement. Now, we have, we're trying to calculate min. So for the string length, we will have banana, which is 6. Banana equals 6. Now, index will be 5. We are subtracting index here from index there, and we should have 5. And we should have, okay, yeah, so let's set oh, it's different one. We're not deleting anything. We should be here. So still, this one's true. So the next operation So the problem here is that, yeah, we incorrectly counting the numbers, obviously. And we spent already hour and a half on just that. But we're moving somewhere. I think we'll do a break for like 10 minutes. And yeah, I will get back. Hopefully there will be some viewers still to see this embarrassment, right? Okay. Yeah, so 10 minutes. I will also try to figure out what's going on there. Um, and yeah, see you in 10. Thank you. And we're back. Okay, so we still have one viewer on Twitch. That's cool. Okay. Yeah, so I just realized that we can't just do this because if we just add a string length of a previous operation to the current index, we will end up in we will always insert at the end. So instead, we should do something else. So let's think about it. So we have hello world, and we have word banana that we want to insert at index 5. So here, okay? Here. So we need to get 5 after calculating the index. So basically we need a shift from previous index to the current one by current index. Current, I mean OP2. So in this case, it will be, I guess it will be transformed index as OP2. Yeah, so we just subtract index of OP1. And in this case, it passes. Okay, cool. So to just confirm that it works, let's add another operation. So we now have, at this point, we should have hello, banana, nah, world. Still can type. Okay, so what we want to do is we want to add something here. Like in the middle of banana, okay? So here, let's add a pipe here so we understand what's going on. Okay, so we're breaking the word in between here. So what will be the index here? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so index 9. We're inserting something at index 9. And I guess it will be 6, 5. Now, we want to confirm that our index here will still be 9. The word will be subscribe. And the last, let's add one more operation because we changed the initial text to be this guy. We can try now adding a word after the last one. So it will be 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 29. Yeah, so at 29, 22. Okay, so we'll be inserting another piece of text at 22. And in this case, we should have an operation to be... The fun part will start when we implement deletion. Well, I mean, when we test deletion. And I'm assuming there could be something wrong as well. And we will add transform here. Like that. Okay. Let's try. No, it fails now. Okay. So it fails. Receive 9, but index is 4. Okay, that's interesting. Yeah, so I guess the calculation here is wrong. So let's see. We have our word banana. And the last operation was at index 5. Okay, so as we are you know what? We're doing it incorrectly. I mean the operations. I mean the testing. But for now, yeah, let's leave it for now. Let's just figure out what's going on here. So insertion. Do we really need? Yeah. Okay. So basically, what's going on here is, after insertion, I guess we don't even need to... Oh, no, we do. So basically what's going on here is that we need to make a conflict here. Okay, so let's say we want to insert 5 as well. We will do this check here. Operation -2 should be banana. Oh, we forgot that we wanted to add spaces around it. And we're adding here at index 9. No, still not passes. I'm kind of lost a little. So what we're doing is, let's see, whoops. What we're doing here is we're inserting word subscribe between N and A here. So banana was inserted at index 5, which was here. And now we want to insert a string here. So this was 5. And we inserted banana. So now, if we just don't do anything, will it work? No, it won't. Interesting. Let's see. Expected 5, got 0. Okay. Plus. I'm just testing different results, you know. String banana. Okay, yeah. Not passing. but I guess we moved to the next one, and index here is 14 instead of 22. Oh no, instead of 9. Let's see. So OP1 will be 5, and OP2 will be 9. And it should stay 9 because we want to add something to the operation, to the string. Specifically, we want to add subscribe in between banana. So in this case, if we don't do anything, it will pass. Yes. And now, let's see, what will happen if we create a delete operation at, so it's supposed to be 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so on index 13, I just subtracted 0. 1, I'm sorry. We will remove a word, world. And then at the same time, we want to add, I don't know, Thomas at the same place. So what should happen is we will have an operation at index 13, 2 operations. That one deletes the preceding word, and then next one inserts another word. Let's comment everything here. I just want to make sure that we're doing it correctly. And yeah, just to be honest, I have no idea what I'm doing. I'm implementing such a thing for the first time, so it's kind of learning curve, and I guess if you never did that, it's learning for you as well. So here I'm just showcasing my train of thought, which obviously is short circuits. So, okay, we have subscribe here in between banana, and what we should end up here, or should end up with here is, let's just copy. It's slightly easier to, so that's our current state. Next will be subscribe ban, subscribe Anna. Next will be we're deleting word, and then you can see that there will be, okay, yeah, so in this case, let's insert Thomas after the word world, okay? So if this was 13, 14, 16, 15, 16, 17, 18, so we need to insert at index 18, okay? And here we should end up with what's going on with my hands? Thomas. That's the final result we should have. So instead of 13 here, oh, okay, so insert is a sum, so we need to, so let's say we have index 18, and we want to drop it down to 13. So we subtract minus 18 from 13, we get 5, and then we just do this. 18 minus 13. Okay. So that's for deletion, by the way. Yeah, and that's exactly what we're doing here. I'm not sure though why we need this thing. We can purely operate on indexes, at least when removing stuff. But at the same time, if we want to insert at the same place multiple times, so let's say we want to insert also at 18. So we're inserting at the last index. So this is what we have after this operation. What we should have after this operation is 18 plus 18 Thomas 1, 2, 3, 4, 5, 6. So it should be 24 minus 24 minus what was that? 18 minus 5. It should be 13. So we go back exactly to this index here. Now it's now we should go to the end of Thomas word. Okay, so we do the same thing, and then add a length of the last operation. Okay, let's try that. So we take current index and we subtract. It's kind of not that obvious, so let's do this. Transformed index minus transformed index minus op1 dot index plus op1 string length. Okay, let's see. But it doesn't work exactly like we want. So it doesn't work in case when we insert it. So we wanted to insert at, okay, so there should be another if op op2 dot index op1 index plus op1 string length. So what I'm thinking is there are two different cases when we want to insert at the end of the string or in the middle of the string or like whatever position. So in this case, we will do exactly the same thing, like exactly the same, I mean the one we did in the initially. So transformed will be plus op1 string length. Okay, that's for the case when we when our insertion operation is at the end of the string. But for every other case, we should do this. Let's try. No, it's not passing. Let's see. So it fails at banana again. So what? Well, let's see. Oh yeah. So we need to minus 1 here. Still at banana. Okay. So where do we do banana? Here. Okay. So it fails here. Oh no, it's not here. Yeah, because we should do this here. And we're checking the last operation. By the way, we can, oh yeah, so we don't even need to do that. I just remembered that we are returning an operation from the process operation method. So we can just grab the final operation here and see what it is. Let's see. Okay, so it now passes. Cool. Now we will check what's going on after here, after this insert. And in this case, we also should end up on 9. And there should be word subscribe, not passing. Let's see what's going on here. Index 5, interesting. So that's interesting. So it inserts at the wrong index. It inserts at index so it does it basically exactly the same, exactly what we tell him to do. So it takes index, and in our case it's 5. So we do 9 minus, what I'm doing here, yeah. So it does 9 minus what? 9 minus 5. plus length. And it will be 9 minus 5 is 4. 9 minus 4 is 5. And length is 6, 7, 8, plus 8. So it should be 5 plus 8. Which is not true as well. So let's see. Do we even get here? Let's debug this a little. Yeah, we do. And oh yeah, it's the first insert. Okay. Actually, that's interesting because we're not. Oh, we just returned a transformed. Yeah. Okay. So how do we end up here? No, it's the first one. It's the second one. Yeah. So we doing this, and that's the first case. Let's go next. So we have 0. Interesting. Why is 0? It's not the previous operation. Huh. That's curious. You see what happened? It took the wrong operation. It took it should have been banana here. It's not hello world. So why it is taking incorrect operation? Okay, so it iterates over each of them. That's what I forgot about it. It doesn't operate on just one. It operates on each of them, so it's different, and I completely forgot about it. Okay. So in our case here, let's just finish it up. Let's go back to our test. So what's going on is interesting because my code here was assuming that we only compare with the previous operation, and apparently it will work if we like do this and -1, and we also need to check if history length is more than 0. And in this case, it should work. No, it doesn't. Interesting. So string subscribe and banana. Okay. It sees banana here. Instead of subscribe. Process operation. Why though? So what's wrong with it? By the way, tell me in the comments if like the length of the duration of the stream is okay for you. Right now I'm not sure how long they should be. So it's what, 2 hours already? I'm thinking about maybe 15 more minutes, and then we wrap it up. So tell me if like 3 hours is okay, or maybe it should be 2, maybe less. So yeah, tell me. So far, we are in a weird place. So yeah, basically, I'm trying to figure out, so, okay, apparently we're not supposed to operate on just last one, I guess, because multiple operations can happen at the same time, and we need to confirm that everything before it is consistent, plus new operation is does fit in this whole system. So apparently this approach with going over every single one of them is okay. So let's remove that. But I didn't think about it for some reason. I forgot about this loop. So, okay. So what should happen is when we insert banana at index 5, we should go through multiple operations here. So first one, in this case, we just compare it with the previous one, and we should pass this point. Interesting. Oh, okay. So yeah, okay, so here we should have banana, but after this one we should have subscribe, right? So let's get back to transform. What should happen here is that transform is going through each operation, and basically we want to insert a word into the banana. Oh, okay, so we're not doing that on the original, on the modified text. We're assuming that we are both working on the hello world. So essentially what will happen is first operation inserts banana here, and the second operation wants to insert a word subscribe at the same place as banana. Okay, so we want yeah, it's incorrect, by the way. So we want to add subscribe here. That's what all the conflict resolution is all about. So basically what we're doing here is we need to understand that where we want to put subscribe, okay? And technically, after this modification here with banana, the subscribe should end up here. So the final string will be banana subscribe. That's fascinating how you, like, during the implementation of a certain algorithm, you start realizing how it works and what's like the purpose of it and how it should behave, and that's super cool. So yeah, so basically when we insert banana here. And actually, it seems like the first approach worked. No, it did not. Okay, so we also want to insert subscribe here at 5, but considering the previous operation, it should be inserted after the banana, okay? So instead of that, it should be at, so banana, 1 space, 6 letters, and 1 space. So it should be 11, okay? And that's where we are supposed to insert the word. And it's not passing, apparently, because I messed something up. I'm not sure why it's not adding the so yeah, now let's see. We have our hello world, and it's at index 0. We need to estimate, so this one is at index 5, okay? Now for the last one, for this change, it's also 5, but here in this case, we already working with hello banana world, and we need to transform it into hello banana subscribe world, okay? How stupid this is. Yeah, so we need to shift our subscribe by 6. So instead of 5, we should get 6. We should get 11. So how do we achieve that? We're just summing the indexes. OP1 index. Index plus OP1 text. String. But the problem here will be that if we, okay, so let's see. We take this 5 and we go from 0. 0, then we take 5, so it will be 5 plus 0 plus how long is hello world? 5, 10, 11. 11. We get 16. Yeah, that's where we got 16. Now, we just need to subtract current index. And we get to 11. Now, on the next operation, we will start at 5. So 5 plus 16 plus 5 plus 7. 6, 7, 8. 8, which will be 21 plus 8, 29, minus index 21 minus 29 minus 16 will be 13, right? Minus 10, 19, yeah, 13. Is that correct? Apparently not. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah. Oh, okay. So it is 13. So the order of operations is take the index, add previous index, add and subtract transformed index. And this should be, I don't understand why it's taking banana. Hello. So this operation is, okay, so let's first this is weird. Yeah, let's, by the way, copy this. And here we should have 13, subscribe, operation insert. Okay. It doesn't show the line number. Or am I missing something? Last OP equal. Oh, okay. So, yeah, I'm an idiot. Not passing. Subscribe, index 13, index 5. Okay, so we messed it up somewhere. We messed it up somewhere. Oh, no. Okay, so it, for some reason, it previous operation. Okay, so index should be equal. Let's add a breakpoint. So we're getting somewhere. Yeah, just let's confirm. So expected index 13, received index 5. Okay, so it did not calculate it correctly, but I guess we are going to figure it out. Okay, so hello world. This is the first operation. Let's go to the next one. Hello world again. Banana, and we're inserting subscribe at index 11. I'm not sure. 1, 2, okay, subscribe. Index 11. Interesting. So, 0 plus 0, 5 plus 0, 5 is our index. Let's do it once again. So this is the first one. Let me make this one a bit larger. Like that. Okay. Yeah, so we're inserting banana at index 5. Now we're inserting subscribe at index 11. It shouldn't be 11. It should have been 16, right? It should have been 16. Okay, so I guess as nobody answered how long they want the streams would be, I guess I'm just gonna do whatever I want. Let's go to here. So at start we have 0 index. We have index 5 from let's add some explanation here. It's current, it's previous, and this is length. Okay. So current. Oh no. Okay. So we subtract no, still not working. Okay, so how do we get 5? How do we get 5? So on the first iteration we should have got 16. For some reason we're getting 11. And 11 is not what we expect at all. Do we actually? Yeah, we do it correctly here. So we're creating an operation from operation itself. By the way, let's do this. Yeah, so just to make sure that nobody messes up with our operation here. It will create a bunch of stale objects, I guess, but at least we make sure that it's not mutating from somewhere else. Let's see. No. Okay, so we're still receiving 5 for some reason. I don't know why. So let's see. Yeah. So I just want to add a. Where's the breakpoint? Oh, yeah. If tran op2 string now, okay. Index 0, index 5. I want also to make sure that we are exiting with the correct index. Okay, so subscribe. So what I'm doing right now is just adding breakpoints that will conditionally fire when we do something. I just want to make sure that here at the return statement, the transformed object is what we are trying to get, or at least we can try to see it. And maybe we can understand why it's not behaving as we want it to behave. So yeah, we're now stopped at the return statement. So let's see, transformed is what? Index 11. Why it's 11? Let's see. So OP1, this guy here. OP2, this guy here. Okay, so yeah, so I want to make sure that the operations we're doing are correct. So we're taking current index, OP1, OP2 index, it's 5, okay, plus previous index, OP1 index, still 5, okay, plus, oh, yeah, okay, so we're, wait a second. 5 plus 0 plus 11, 16, 16 minus 5. Okay, so maybe, no, it's incorrect. This math is incorrect because here at line 1, I mean, here, we were supposed to end up at 16, but in fact we're ending up on 11, which I just got. So and we take length of OP1 string length. It's 16. Interesting. So it should be 16 here. And oh yeah, it is. And then we do OP2 index, and it's 11. Okay. And on the next step, we take 11 plus previous plus 5 plus 8, we get 24. And minus 11. Still, it still should be. Oh, we didn't subtract the index here. Oh, we did. Okay, so I'm not getting why it's. It's still 5. Why it's 5? It should be something else at least. Why it is 5? Apparently it's because no. Otherwise this thing here would have been called. Okay. So let's see. So obviously what I forgot what I wanted to say. Okay. So, what do you guys think? What could be the problem here? So, the math is correct. Why the index is not? Do we actually check the correct operation? Let's see. OT history at minus 19. That's better. Okay, so at least we have some change. Why it's 19 though? That's at least something. Now it's 11 for banana. Wow. Why though? Let's see. So what do we start with? So we start with 0. And then we go 5 plus 0 plus 11 equals 16. Okay, so I see the problem. I see the problem here. So it doesn't count correctly for the first operation, okay? I guess if we, like, I guess if we do, for example, this and run it again, oh, okay, doesn't work. 19, interesting. So 19, 5. That is curious. So we have like 20 minutes left. I will try to fix it to this point where both operations work. Unfortunately, I guess we won't get to WebSocket stuff, which is kind of more exciting than all of this. Probably this is also interesting, but like seeing it in action should be quite fun. And we will do another stream on, I don't know, Wednesday, for example. Slightly later, apparently roughly at current time. And it will be like maybe 2 hours. So we'll figure it out if we want today. Because I feel like we're close, but I'm missing something. And I'm not sure what. But anyway, tell me if that's okay. Tell me if that's okay. I don't... Is the chat broken or am I missing something? Let me check quickly. Okay. Nothing here. Nothing here. Okay. Okay, cool. So feels like my screens here are not in sync. It's completely different stuff going on in Twitch and on Facebook. Anyway, let's try to fix it, because I don't understand now. Okay, so I have no clue why it is doing that, but let's see once again why, not why, but like what it outputs. Okay, so just happened. Did I? No, I still have my breakpoints here. Okay, so 16. So how do we return back to 0 to 5? I mean, of course we can do an exception, like if OP1 P1 index is 0. Let's just keep the something like that. We should pass. Yeah, we're passing now. I guess that's cool. Now let's go back to. It's annoying that we will need to like perform all this math to calculate like next step, but I guess we're good so far. We confirmed that operation worked. We can delete all of that. I will leave this part here, and I'm assuming that in 15 minutes we won't be able to finish anything. Let's see what's left. I guess one thing that we want to do is we want to try collapsing all the transformations to receive a final text to just see that everything worked. Okay, so how do we do that? Apparently, no, nothing. Okay, so let's call it collapse. We don't have any parameters here. So well, there will be a final document. And now we need to apply every operation that we have. And I guess we will be doing the same thing here as we did before. So for now, we will test insertions. I think deletions will work just fine because I looked at the code and it feels like it's correct. Well, yeah, it's obviously always a bad thing to assume that your code correct until at least tests confirm that. But for now, I can't say I care too much. So yeah, okay. So we need to go through every operation. So for let op of this history. And what we're gonna do is we want to apply every operation. So let's just do text. No, not text. Why? I'm calling it text. Maybe we should rename it. It's string, index, and type from OP. Okay. So yeah, types are correct. Now switch type. Case. Operation type insert. And now we want to yeah, break. Oops. Okay, cool. So what are we gonna do? What we're gonna do is we're gonna apply inserts. So basically what we need is oh, by the way, we don't want that because it should be empty string because the first operation is inserting at 0. So we don't have our document yet. Okay, so I just have my notes here to kind of it's kind of script, but not script. I don't want to call it script. So final document equals we want to so we want to cut our text in at the position. We can I remember there was a new API. Let's check it. Oops, not what I meant to do. Not what I meant to do. There was this new API called slice. Yeah, there is slice. Nice. Okay. So basically what we can do here is we're just taking our document, slicing it. Oh, it doesn't have slice here. Okay. I guess slice can accept start end. Yeah. Yeah, so basically what we're doing is we're slicing at 0 index plus string plus document slice index. Yeah, so let's see. Let's write a new test. I mean, we can just continue here. This is collapse operation. And we want to return final document. And now, expect OT collapse. To equal hello banana subscribe world. And it's not passing because we have extra space, because we added space. It worked, but yeah, we just didn't want this space here. And hello. Oh yeah, we're interesting. Oh yeah, okay, yeah. So we inserted right after banana, and we added 2 spaces, one added by banana and one existed before. So now we're passing. That means the order of operations is preserved, and yeah, so, and we're right in time. We have just 6 minutes left, at least at my schedule, and yeah, so I'm ready for some Q&A. If you want. Let me just. Where's my browser? Ready for some Q&A if you'd like. Yeah, ask your questions. I'm happy to answer whatever. Yeah, but about the code, that's it for today. And yeah, I guess we'll see. We'll meet back on Wednesday. That should be good. Yeah, I guess we're left with deletion that we didn't test at all, but insertion at least is cool. Yeah. next time deletion should be much simpler because we already know how this whole thing works. After that, we can start the real-time part. We will set up a WebSocket server. We will set up client and server code for clients to interact via the WebSocket. And maybe if we'll have time, but apparently we will not, so there will be a third stream maybe. We will try to optimize it a little bit and introduce an update command, operation type. But maybe not. I don't know yet. Maybe next sprint will be just enough for us to understand and implement the algorithm finally. Yeah, so there's no questions in the chat so far. I guess there's no question at all. So yeah, thank you for watching. By the way, I forgot about something. I will not be doing only streams. I will also be doing videos on my YouTube channel. So consider subscribing there. I'm not sure if I left a link on Twitch. Let me see. Let me see about. Yeah, okay. So I should add a link to YouTube on Twitch. But you can find a link in my Telegram channel. There's this thing as well. But I will add a link to Twitch as well. And by the way, the code for everything will be available on GitHub. I will also drop a link in the description to the recording. And it also will be in Telegram channel. So you're free to add PRs or ask questions there in the issues. Yeah, I guess I don't have anything more to say. Thank you for coming. Consider subscribing on Twitch, either on Twitter, on YouTube. And yeah, thank you. See y'all on Wednesday.